Hello guys, today we are going to solve this Leetcode question which is missing number. It's basically an easy problem, but in the interviews, the interviewer might ask us to optimize the solution. We can solve this by using number of brute force approaches, but the interviewer might ask us to optimize the solution. So in this video, we are going to see 4 or 5 approaches to solve this question. And basically we'll start from brute force and we'll go to a slightly better way, and from there we go to efficient one and the most optimal one that we are able to solve this question with. So this is how this video will be. And okay, let's start the video. Let's go into the video. So in this question, we are given an array nums containing n distinct numbers in the range 0 to n. So this is the most important thing that we need to, identify. Return the only number in the range that is missing from the array. So we're basically given n. Suppose let's say n is 2. So in our array, we will have values from 0 to 2, but you know the array may there may be an element which might be missing from the array. Let's say 1 is missing from the array, so we'll be given this array and we need to say that we need to return that 1 is missing from the array. So let's look at these examples. We're given this array, uh, the number of elements n is 3, right? So our array should contain from 0 to 3. But in our array we have 0, we have 1, but we don't have 2. So 2 is the answer, and we have 3 as well. In the array, there is only one element which will be missing. There cannot be multiple elements which can be missing. So that makes the question very easy to solve, right? So in this, we're given 2 elements. So here n is 2, right? So our array should contain from 0 to 2. 0 is already present, 1 is also already present, 2 is not present, so 2 is the answer. This question we have from 0 to 9, and the 8 is missing, so our 8 is the answer. So in this question, the constraints play very important role, right? you know uh, you can I'll explain why the constraints play a major role in this question while I'm explaining the solution. So in this question, n is nothing but nums dot length. The the number of elements can be at most 10,000, 10 power 4, right? And the value of n can at most be, sorry, the value of the array, array element can at most be n. This is the most important thing we need to take care of. And all the numbers of the array are unique. This is also the most important thing. Now, using these two conditions, we can optimize the solution, you know, way better. So let's see how are we going to solve this question. The the let's say what's a brute force solution that we can come up with. Now, let's say I have this array, or let's say I have this array. Let me copy paste this. Let's say I have this array. So what I'll do is, I know that in my array the element should be from 0 to n, right? So what I'll do is, I'll use a for loop. Which goes from 0 till n, and for every value of I, I'll see, initially my I is 0, right? So I'll go through the entire array and see whether 0 is present or not. 0 is present. So the I will become 1. I'll check if 1 is present or not. 1 is present. So I'll go to 2 and I'll check, but 2 is also present, 3 is also present, 4 is also present, 5 is also present, 6 is also there, 7 is also there, but 8 is missing, right? When my I becomes 8 and I traverse it through the whole array, and I cannot find the 8 in my array, right? So I can say that 8 is my answer. Here 8 is the answer, right? So this is one of the approach. Let's what is the time complexity? For this for loop, we're going from 0 to n, right? So it will be order of n 2, and for each element we're going through the entire array, and the size of the array is n, right? So the worst case time complexity will be order of n square, right? And what is the space complexity for this approach? Is order of 1. Since we are not using any extra arrays or any other data structure to store the value, the space complexity is order of 1. So if you say this approach in interview, the interviewer might not be happy and he will ask you to optimize the solution. So let's optimize the solution. Let's say a good way, a good approach. Let's think of a good approach. If you observe here in this question, suppose we are having 0, 1, and 3 in this array, right? But we know that it should contain 0, 1, 2, and 3, right? 0, 1, 2, and 3. In this approach, what we are doing is for every element, we're traversing the entire array, right? We're traversing the entire array. So because of traversing the entire array, our time complexity is going to order of n, right? Order of n square. I'm sorry, order of n square. So we're getting this extra n because of traversing to the entire array, through the entire array. So what we gonna do in this approach is we're gonna store these values in a set. What I'll do is I'll store 0 in the set, 1 in the set, and 3 in the set. And I know that my array should contain 0, 1, 2, and 3. So what I'll do is I'll use a for loop which goes from I equals to 0 to 3, the same thing that we did in the previous approach. But in this approach we're using a set. So I'll check if my 0 is present in the set or not. It is present, right? Then I'll check if 1 is present in the set or not. It is present. Then I'll check 2. 2 is not present. So 2 is the answer. So how did we optimize in this solution? We're basically doing the same thing here and here. But what's the difference is provides us set helps us to search an element in order of 1. So we don't need to traverse through the entire set in order to check for an element. We can directly go to the element in order to identify whether it is in the set or not. How it works is that suppose if we have 0, the set we basically call it hash set, right? So we basically use hashing. you know it is generally passed through a function called hash function, and we basically have a bucket bucket and when an element goes through the hash function, this hash function calculates a random index and stores the value that random index 0. Suppose we pass 1, it will find a random index and it will store 1 there. Suppose if we pass 2, it will store 2 there. Now when I ask is 1 present in my hash set or not, it directly goes and identifies the location in order of 1 time. So this is how we're optimizing the solution here. In this approach, the time complexity is order of n, because we're going from 0 to n, and inside the loop we're only using order of 1 space, right? Order of 1 time complexity. So order of n into 1 will be order of n, right? And the space complexity is, since we are using an additional set, and the set may contain at most, in the worst case it might contain n elements, right? So the space complexity is order of n. So this is a basically good approach, but we can also, the interviewer might ask us to, you know what they call, remove the extra space that you are using, right? So how can we do that? A better approach, I don't think it is a better approach, but it is one of the approach. Is that, the approach is that, suppose we're having an array, right? The array, suppose the array contains 1, 2, 3. Suppose the array contains these elements, but in the question, they mentioned that the array should contain elements from 0 to 3, right? So the array should be like this. It should be 0, 1, 2, and 3. It should be like this, right? So let's say, the let's say our array is not like this. Let's say it is something like this: 3, 1, and 2. So what I'll do is I'll just sort this array, then 1, 2, 3. It will become like this, right? So in a sorted way, this is our resultant array, right? In the resultant array, if you observe carefully, our index is 0, our index is 1, our index is 2, our index is 3. So the element should be equals to the index, right? The element is equals to the index. So in this array, we're having 0, 1, and 2. But here the element is not equals to the index. So 0 is the one which is missing, right? So in this way we can also solve this question. But what is the time complexity? The time complexity for sorting is order of log n. When it comes to space complexity, we are not using any additional space. So the space complexity is order of 1. So let's try to solve it using a more, better approach, because in the interview the interviewer may ask us to solve. I'm sorry. He's asking us to, solve the question using order of 1 extra space and order of n runtime complexity. But we are having order of n log n. In this approach, we are having n, but we are also using a space complexity of order of n. Here, the time complexity is way too much, which is order of n square. So now let's try to optimize it more further, like an efficient, I might say, let's say an efficient approach. In this approach, if you observe carefully, we have an array, right? Suppose we have an array like 2, 3, 1, 5, 0. So in this, we are having 1, 2, 3, 4, 5, right? So our answer should, what is the element that is missing from here? The element that is missing is 4, right? 4. So if you observe carefully, uh, if you add up each and every element here, 2 plus 3 is 5, 5 plus 1 is 6, 6 plus 5 is 11, right? And what is the what if the element 4 is also present in the array? The resultant array should be 0, 1, 2, 3, 4, and 5, right? So let's add this: 0 plus 1, 1, 1 plus 2, 3, 6, 10, 15, right? 15. So this, our overall sum should be 15, and the sum that we are getting is 11. So if you subtract 11 from 15, you will get the missing element. So I hope you got the idea. And there is no need to loop through the entire thing and find the sum of this, right? You can do it in order of one by using a mathematical formula, which is sum of the first n elements, which is n into n plus 1 by 2, right? If you use this formula, you'll get this sum, and you'll loop through the entire array and find this sum, and you'll just return the difference between these two. That's it. So I hope you can code this up by yourself. So now let's move to the most optimal solution. I think this is the most optimal solution. Let's see another optimal solution, which is of, oh, sorry, we forgot to find the time discuss the time and space complexity, right? What is the time complexity? So we'll just loop through the entire array to find the sum, right? Which is order of n, and we can find this in order of 1. So this is the time complexity. The space complexity is order of 1, right? Since we are not using any extra space, we're not going to store this array, right? You need to you need to understand that we're not going to store this array. We will just find out the sum by using this formula. So let's discuss the most optimal or the fifth approach. So let's say our array is like 1, 2, 5, 4, 3, 7. So the number 6 is missing, right? The number 6 is missing. So what we can do is, we can generate another set of numbers like, oh, 0 is also missing. So I'll add 0. 0, 1, 2, 3, 4, 5, 6, and 7, right? So this is the resultant array. So what I'll do is, I'll keep a variable called XOR, and I'll do the XOR of all these elements, you know. So before that, you need to know the property of XOR, which is if you have an element A, let's say the element is n, you XOR it with n, the result will become 0, right? Suppose you have an element n and you XOR it with m, and you again XOR with n, the result will be m, because this value and this value will get cancelled with each other, and you'll only be left with the element. Suppose if you have something like n XOR m XOR o XOR m XOR n XOR o XOR p. Let's say you have these values. This n will get XOR XORed or cancelled with this one. O will cancel with this one. M and M will be cancelled, and you will be left with P. So using this idea, what we'll do is initially we'll XOR all the elements. So I'll XOR all these elements. Then I'll XOR with the elements which I have in the array. So when I XOR with these elements, 0 will be cancelled with this 0. 1 will be cancelled with this one, 2 will be cancelled with this 2, 3 will be cancelled with this 3, 4 will be cancelled with this 4, 5 will be cancelled with this 5, 7 will be cancelled with 7, and at the end we'll be left with 6. So this is our answer. So let's try to code this up. I'm only going to show the code for the last approach. So initially we'll take an XOR variable of XOR variable. I'll just I'll just go from 0 to n. N is nothing but nums dot length, right? I'll do XOR equals to XOR I, right? And what I'll do is I'll just go through the elements in my array, and I'll again do the XOR with all the elements, right? And in the end, I'll be left with the element which is missing. That's it. I submit this. Yeah, is accepting fine. So these are the 5 approaches that we can solve this question. And if you look here, this question has been asked in so many companies. So this is an extension that you can also use, which is called, I guess it is Leetcode Premium Unlocker. I don't know, but I don't know. It could be this extension as well. You can have these extensions. That's it, guys. Thank you for watching the video. And if you find the video helpful, then like the video. Thank you.